and welcome. During the course of our tuition for some of our students taking the foundation and also the intermediate course, there seems to be a little bit of trouble understanding the different ways of noting numbers and describing numbers. So today we're going to go through scientific notation, we're going to go through a bit about decibels, and we're going to go through the different markers that we see throughout numbers like kilo, milli, micro, etc. And hopefully this will help to clarify what's going on and how it all works. So in the beginning we start out with a number. So let's start out with number 1. So number 1, straightforward. With the types of units that you're going to be using in this hobby, you tend to be using thousands, millions, etc., or thousandths and millionths of a value, and they tend to be clustered in groups of 3 zeros. So if we go from 1 to 1000, these 3 zeros here can be represented by a lowercase k, and this is short for kilo, which means thousands, or 1000 or thousands. So you could have kilo ohms, kilometers for distance, kilovolts, etc. It applies to everything. So 3 zeros is denoted by the lowercase k and kilo. And that means thousands. When we go further, we can end up with another 3 zeros. And now we're into millions. So 1,000, 2,000, 3,000, 100,000, 500,000, 900,000. Eventually we roll over to the next 1 value, which is 1 million. And 1 million, which is 6 zeros, so we'll do it like this. So 6 zeros across here is millions. And it's 2 sets of zeros, as you see here. So with millions, we use the capital M, and this stands for mega, and that means millions. Okay, so mega ohms, megavolts, mega whatever value you're using. So if you see mega, it means millions. 1 mega ohm is 1 million ohms. Okay. The most you'll see really is another 3 zeros, in which case that would then be 9 zeros. With 9 zeros we use a capital G for giga. Gigabytes, gigahertz, giga ohms, although you rarely see values that high in certain units, and therefore it doesn't sound right because we don't typically hear it. And this is actually billions. So we've got kilo or kilo ohms, kilometers, etc., which is 1,000 meters, 1,000 ohms, 1,000 volts, kilo ohms. We then go to 6 zeros, and that would be M for mega, which means millions. And then we have 9 zeros, and that's then G, capital G for giga and billions. Now why bother with all this? The reason being, if you're doing a calculation and writing down the value of something, it can be tiresome and awkward to write such a big figure over and over again. So in our case we can comfortably and easily write 1 mega ohm plus 2 mega ohms equals 3 mega ohms. This is nice and concise, it doesn't take up too much space on the sheet, and easy to deal with. So it's just a way of contracting the size of the writing. So if we look back at this figure here, there are other ways we can do this as well. Okay, one of them is called scientific notation, and this would be to realise that we've got a figure number 1 here and then a load of zeros. So we could write this as 1 and then have some kind of notation that said and 6 or 9 or 3 zeros. And that's what scientific notation does. So if we look at this value here, even with the 9 zeros, we can write as 1, and we usually do it to 1 decimal place. So we'd say 1.0, and then how do we notate the 9 zeros? We say times 10, because obviously each one of these is just times 10 of each other. Tens, hundreds, thousands, tens of thousands, and so on. 1 times 10 to the power of, and then however many zeros. So with this here, we have 9 zeros, so we'd write 9 at the top there. So how do we decipher this? When you see this scientific notation, we have a number here, 1.0. So if we were deciphering this, we could write 1, and then 0, obviously there's no value to it, and then 9 zeros. So we'd say 1, 1, 2, 3, 4, 5, 6, 7, 8, 9. There we go. That's all that means. But it's a lot shorter to write this than it is this. There are additional benefits to it which I won't go into because you won't come across them at this level, but you can actually add and subtract numbers and multiply them, etc., and then just using this small number here you can calculate the answer quite quickly and easily with it. Again, I won't go into that, but just know that there are additional benefits to doing it this way. It clarifies how to get to an answer quickly and easily. So this is scientific notation. Again, the little number at the top here, this indices, indicates the number of zeros that follow the decimal point here. This could be 1.2, so you'd have 1, 2, and then you'd count 9 decimal places from where the point would be. So the point would be just here, and we would count 1, 2, 3, 4, 5, 6, 7, 8, 9, and so on. So you're just filling in the zeros after that decimal point. Because this first character here has a value of 2 now, it wouldn't be a 0, it would be a 2. You'd still count that as one of the 9 decimal places that you're adding. Okay, so this is scientific notation. Let's call that SN. Next, let's look at decibels. So with decibels, we've learned already that times 10 is the equivalent of 10 dB. So we know that. We also know that 20 dB, the 2 means 2 sets of zeros. So this would mean times 100. 30 dB means 3 zeros, so times 1000. So if you can see here, this first figure here denotes the number of zeros that go on the multiplier. Okay, so we're talking about tens here because this is a multiple of 10. It's tens, and then how many tens? 2 zeros, 3 zeros. So let's just do a quick test ourselves here. If we've got this here, which is 9 zeros, what would this be as a decibel? 1 billion, what would it be? So that's going to be times 1, 2, 3, 4, 5, 6, 7, 8, 9. Yep, hopefully you've got this. It would be 90 decibels. Here's the 9, look, 90. Yep, so 9 zeros would be 90 decibels. So I hope, certainly if you're counting in tens, this helps you to understand how to quickly and easily identify what sort of number you're dealing with. Hundreds, thousands, and so on. Okay. This first digit in the line here denotes how many zeros. Okay, so let's have a look at going the other way now. So we've talked about big numbers. I think the next thing to talk about is small numbers. So if we've got 1 again, but we're going in the opposite direction, So here we have 1,000th. We know that because the decimal point would travel 10, 100, 1,000 times to get to here. Okay, so this would be 1, and this is 1,000th of 1 with it here instead. So what do we call this then? Let's go back to the beginning here with the words. So 1,000th, you may have heard of millimeters, which is a lowercase m. The word is milli, and that means thousandth. Okay, so that's 1,000th. Now if we continued to add, so we go 1, 2, 3. So 1, 2, 3. If we had it here instead, forgetting this one, yeah, this would be 6 decimal places. Okay, 0.00000. 1, 2, 3, 4, 5, 6. So 6 zeros. You've got to include obviously the one to the left of the decimal point. So 6 zeros, 6 decimal places to the left of the number 1 is 1,000,000th. Okay, so this here is this bit. This here is 1,000,000th. Now this is slightly different in that we use the Greek letter mu, which is an M with a long leg, or a U with a long leg. A U with a long leg is probably a better description. And this is micro. Micrometer, yeah, microwave. So, microwave, micro means millionth. Millionth. Okay. So this is 6 zeros, or 6 decimal places to the left of a number 1, a single unit. Okay, so that's millionth, micro. And so on. You can go to N for nano, which is another 3. That would be 9, or a billionth. And that would just be another 3 zeros on the end. So 1, 2, 3. And then we have pico. You will come across pico, which is a lowercase p. Pico, and that's a trillionth. So that's 12 zeros. So this is 9 decimal places. This is 6 decimal places. This would be 12 decimal places. And a trillionth. Okay, so as you can see, this is very logical. We're just going in jumps of 3 decimal places each time. 1, 2, 3, milli. 1, 2, 3, micro. 1, 2, 3, pico. And if we went another 3, that would be, nano. Another 3 would then be pico. Yep. Milli, micro, nano, and pico. So again, it's logical. Just remembering, obviously, which word goes in which order is important. But this is something that's straightforward to get to grips with. In terms of decibels, again, it's very similar. Scientific notation. Let's go back to this first. So with scientific notation, you'd have 1 times 10 to the whatever the number is. We use exactly the same form here as we already understand. Exactly the same, except for one thing. We put a minus in front of the indices here to indicate that this is a small figure, meaning we're going to the left, as opposed to a big figure where you're counting the zeros to the right. So instead of having 1 billion here with 9 zeros and having this notation, what we would have is, I'll just write this out again, we'd have 1.0 times 10 to the negative 9, which would actually, again, that's where the 1 times 10 to the 9 to the negative 9 would look like this. Oops. Like this. So 1, 2, 3, 4, 5, 7, 8, 9. Yep. So it would be this tiny number here. 0 point and then 8 zeros and a 1. Okay, so to the negative 9 means this. Okay. Another thing you might see as well, and just to explain it a bit further, is that this number is the equivalent of 1 divided by this number. So 1 times 10 to the negative 9 is the same as that. Okay, imagine the negative here as being the line that you draw for the division. Okay, so this is the same as this here. Alright, so that's the scientific notation. I doubt you'll have anything complicated to have to do with this, but just getting your head around how it works will help you no end for learning for your exams, etc. With decibels, it's very similar too. We just have a negative figure, so negative 10 decibels, which is the equivalent of a tenth. Negative 20 decibels would be 1/100th. Negative 30 decibels. So we're just adding a 0 each time. It's getting a tenth of what it was before. 10 times less each time. And again, this figure here with the negative sign, it just means you're starting off moving to the left, getting smaller each time. So minus 30, the 3, means we're going to jump over the tens 3 times. So from 1, we go 1, 2, 3, and that would be negative 30 decibels. So I hope that helps. If you have any questions, please post them in the comments or contact us in other ways by email, etc. And I hope this helps you. If you do have any questions, again, please post them in the comments and we'll try and get to them all.